And well, I just wanted to do a brief welcome to everybody. Good morning. My name is Ashley Rude. I'm co-director of Oregon Climate and Agriculture Network. Welcome to our October 2022 Climate Resilience Training for Oregon Ag Professionals. So we're trying a new format this year with dividing up the training into weekly workshops every Wednesday versus a more intensive 3-day virtual event. I really look forward to your feedback on that. We're gathered here today in the Zoom room with colleagues from across the state and even some from further afield to take time each Wednesday to bring the idea of climate resilience on Oregon's farms and ranches into focus. You know, we're really here today because we can't do this work alone, and we can't do this within our usual boxes, really disconnected with one agency over there, a nonprofit over here, and researchers somewhere else. We really need to connect. So we're gathered here today to do just that, to create a community of practice dedicated to supporting farming and ranching for climate resilience in Oregon. We're going to make resilience tangible and accessible over this series with both place-based knowledge and science guiding the way. Over the next 4 Wednesdays, we've developed a program that many of you helped plant the seeds for, and we hope that you'll see through the workshop agendas that we're listening. We've heard that you really want to keep up with the latest in science and how to better communicate about it. We've heard that case studies of resilience are one of the best tools that we have to better understand what we need to do next. We've heard that you're curious about how policy and environmental markets will impact growers throughout the state. And these are just some of the steps that we'll be making on our workshops over the next few weeks. We've also heard that you want place-based information, tools, and partners. So you're going to find a theme throughout these workshops, throughout the series, that we're going to facilitate regional breakout rooms for conversation and problem solving. Thank you for being ready to meet and interact with your colleagues. I'm so excited about the depth of knowledge in this room. Over the 4 workshops as we gather, let's embrace some grounding agreements. Let's all gather with respect for others by listening with curiosity. Let's speak from our own personal experiences, and let's allow time for others to share. Some quick Zoom guidelines. Please keep your screen on as much as possible. I know it can't be on all the time. Keep yourself muted when you can. And please use the chat box, but keep conversation relevant to the main presentation. And if you want a reminder of what we're going to cover today, our agenda is online. And I think Megan Montgomery will be able to throw that in the chat here in a minute. Thank you, Megan. She's also going to be keeping an eye on the chat today. And the agenda, you'll see that today we're going to be flowing through breakout rooms and speakers. And just as we're going to need an interdisciplinary community of practice to move farming for climate resilience forward in Oregon, I really needed an interdisciplinary team to pull off this Western SARE funded program in collaboration with OSU Extension. So I'm happy to turn this over to Amy Garrett in a moment to help introduce our planning team that's helped shape this program and get the word out. Of note, the planning team introductions are kind of a model for what we're going to be doing in just a minute. We're going to ask each of you to go into breakout rooms with just 1 or 2 other people to do quick introductions ahead of our panel of speakers today, kind of setting the tone for having an interactive session. So thanks again for making the time for this today. It's really important, and we really can't do this alone. Amy, I'm going to hand it off to you now.
Thank you, Ashley. My name is Amy Garrett. I'm with Oregon State University Extension Service Small Farms Program, and I also serve on the board for the Dry Farming Institute. And I was really excited to participate in this planning committee again this year because I think that climate change and water and drought are one of the biggest things impacting the growers that we work with, especially a lot of small and mid-sized farmers. So I'm very excited to be supporting ag professionals and doing this work as well. And I'm going to kind of go around the planning committee here and let each of our planning committee members introduce themselves. So Cheyenne, I'd like to pass it off to you next.
Hi, I'm Cheyenne Gajara. I'm OSU's Organic Pasture and Forage Extension person housed at the Center for Small Farms and Community Food Systems. And I'm interested in this topic for 2 big reasons. One is that for most of my stakeholders, it's kind of their biggest concern in producing forage and pasture-based systems. And for me, I think it's kind of a matter of societal survival and survival, hopefully. So yeah, thanks, Amy.
Thank you, Cheyenne. Hannah Gosnell.
Hey everyone. My name is Hannah. I'm a professor of geography in the College of Earth, Ocean, and Atmospheric Sciences at Oregon State University. And I've really enjoyed working with ORCAN in the past couple of years. As an academic, I really want to be sure that my research is relevant and useful to the practitioners that I study and learn from. And so I see myself as sort of a bridge between academics, and the practitioner world. So I really value the opportunity to get this feedback from people who have real on the ground experience to make sure that my research stays relevant.
Thank you, Hannah. Gordon Jones.
Good morning, all. Gordon Jones with OSU Extension down in Southwest Oregon. I have a general agriculture appointment serving Jackson and Josephine counties. I'm new to the West as of maybe 5 years ago, and feels like arriving in the Rogue Valley. We're really seeing some of the crux of a changing climate with drought and catastrophic wildfire down here, as well as some changes in land ownership and shifts in the agricultural landscape, and want to be able to support practitioners with good science and resilient practices going forward.
Thank you, Gordon. See next, Catherine Minthorn.
Good morning. My name is Catherine Minthorn. I'm a member of the Confederated Tribes of the Umatilla Indian Reservation here in Eastern Oregon near Pendleton. I'm a technical assistant specialist with Intertribal Agriculture Council. I've been here 22 years, and I serve the tribes of Oregon and Idaho.
Thank you, Catherine. We have quite a few other people on the planning committee, but I don't see them logged on just yet. So I'm just going to go ahead and name them. We have
Amy, we do have
more?
Megan
Thank
Montgomery
you.
on the call. Yeah.
Thank you.
Hi,
Megan.
my name is Megan Montgomery. I work with Jackson Soil and Water Conservation District. I'm the agriculture resource conservationist down here. And I'm interested in this topic for kind of similar reasons to everyone else. I work with agricultural producers and land managers down here, and kind of pretty drastic changes in water supply and sort of temperature trends and things that have people pretty concerned for the viability of production in the long term.
Thank you, Megan. Am I missing anybody else? I think that is all that I can.
We've got Cory. Have you introduced yourself yet?
Yep. Thank you, Cory.
No worries, Amy. Hi, I'm Cory Owens. I'm the Assistant for Partnerships with the Oregon Natural Resources Conservation Service. I'm also the NRCS Northwest Climate Hub co-lead covering Oregon, Washington, Idaho, and Alaska. And as part of USDA Undersecretary Tom Vilsack, climate is one of his top priorities. So very interested in being able to bring good technical information about this topic to not only our own staff, but the greater conservation community throughout the state, so we can all be thinking about climate in new and innovative ways.
Thank you, Cory. So the other few people that I think are not logged on just yet are Maud Powell with the OSU Extension Service Small Farms Program in Southern Oregon. We also have Jesse Kirschner with the Water and Climate Program. And Lisa.
I'm here.
Oh, you are. Thank you. Okay, please introduce yourself.
Hi, everybody. Good morning. I'm Jesse Kirschner. I'm the Water and Climate Programs Coordinator at the Oregon Watershed Enhancement Board, and was interested in joining this planning team. My background is in training, and particularly around climate adaptation and resilience training, and so was just excited to think about how I like to help people think about how climate impacts the things that they care about, what they work on, what they manage, and then to help to develop adaptation and resilience strategies. So this was just an opportunity for me to step into that a little bit more. And I also am excited to learn a lot just from you all about the challenges with Oregon agriculture. I know less about that aspect. And so just really looking forward to hearing the things that people have to share.
Thank you. So I think the only two remaining that maybe are not here, and if you are, please speak up, are Lisa Kilders. She's an Outreach and Education Program Manager at the Clackamas Soil and Water Conservation District. And also we have Heather Medina Sauceda with the NRCS. She's the Assistant State Conservationist for Field Operations, as well as Holly Prenville with the Northwest Climate Hub. If there's anybody I'm missing, I'm very sorry.
No, you did great. Thank you so much, Amy. I really appreciate that so much. And as I noted at the top of the meeting, we're trying to mix things up a little bit from your typical, sign on to a webinar and kind of check out and multitask. And we want this to be really engaging and interactive. So with that in mind, in a few moments, we're going to shift everyone into breakout rooms with one or two other people. Emmerich, what do you think? Will be maybe two other people or one other person? I'm sorry.
It looks like most groups will have two folks, but we might have one or two with three.
Okay. And just so folks know, the recording is just happening in this bigger breakout room. So when you jump into a breakout room, there might be one of those audio cues again. So for this particular breakout room, this is just for introductions. We've got a lot of people on the call and we want to create some personal connections. So when you get into your breakout room, introduce yourself, let folks know what organization you're from or how you're getting to this meeting, your location, and just share with the other person what piqued your interest about signing up for this particular event. And then when you come back in from the breakout room, we'll have you share just like a one-word reflection for what you heard in meeting this person that you're going to be in a room with. So with that, Emmerich, if you could go ahead and let people out into breakout rooms. Thank you. Welcome back, everybody.
This meeting is being recorded.
Oh, let's make sure everybody is on mute again. Welcome back to this space. How did that go? Do we have some thumbs up, some thumbs down? Oh, love it, love it. If you want to type in the chat, just reflecting back one word that you that really resonated with you that maybe you discussed in your breakout session, that would be fun. We'd love to see what started coming up for people. Loving seeing a lot of connection and community. It's hard to do on these Zoom calls, so. Love it. This is great. Love seeing all of this. Okay, with that, I'm really excited to transition into our first small group of speakers, and I'll pass it along to Jessie, if you're there.
I'm here.
Great.
Thanks, Ashley.
Thank you.
That's why you can't see me amongst all the people that are here. You're like, which screen are you on? Well, good morning again, everybody. So as Ashley mentioned, this is the first of 4 sessions. So in this session, we're going to have 3 presenters. So I'm going to introduce the first 2, and then we'll have the third go after a little breakout group activity. But we're going to be diving into more information on the climate impacts and the science in the state of Oregon, how producers make decisions about resilience, and how we can manage risk with soil conservation practices. So we're going to have 2 speakers, Erica Fleishman and Hannah Gosnell, both with Oregon State University. And then, as I mentioned, we'll spend some time in breakout groups before coming back together for our final speaker, Cory Owens from NRCS. So I'm going to introduce Erica and Hannah, and then we'll go into their presentations. I would like everybody to please hold your questions until after both Erica and Hannah have gone. So if you have something, jot it down, and then we'll have a larger group Q&A after both of them have had a chance to present. So Erica Fleishman is the director of the Oregon Climate Change Research Institute and professor in the geography program at Oregon State University. He has more than 25 years of experience conducting research on ecological and associated management responses to environmental change in the Western United States. Erica has also worked with rice farmers in the Central Valley in California on land use practices that may sustain both economic viability and rare species. And then Hannah Gosnell is a professor of geography at OSU. Hannah studies agricultural landscape change, water resources, climate change, and environmental governance in the context of rural working landscapes. She's particularly interested in the social, cultural, and psychological aspects of the transition to regenerative agriculture and the implications for landowners' capacity to adapt to changes. And she is a program advisor to ORCAN. So again, I'm going to turn it over to Erica, who will share her screen and give a about 15-minute presentation. And again, if folks can hold their questions until the end, that would be great.
Okay, can you hear me all right? Great, thank you. It's a pleasure to join you all this morning. Usually I say just break in if you have a question, but we can hold until the end too. So thank you very much. Whoops, alrighty, let's see. Here we go. All right. I like to always begin when I'm talking about climate change by emphasizing to myself and to everyone that climate change is happening against a backdrop of land use change. And for about 50 years now, there's been this concept, it's not a literal equation, it's more of a concept, that environmental effects or environmental impact are a combination of how many people there are in a place, could be a state, could be a region, could be the whole world, their consumption, which is often related to their affluence, and technology. So this may be a familiar concept to some of you, but basically we're talking about, that people's effect on the environment usually is some function of the amount that they're consuming and how technology either increases or decreases that consumption. And environment in this case includes infrastructure, it includes sort of the mental environment or the emotional environment. It includes public health. It also includes the natural environment. So climate change, there would be a lot of stresses in agriculture or any other sector and a lot of need to consistently adapt, even if climate change was not happening. But of course it is. So sometimes people throw a lot of words around in any particular field and it's easy to forget that everyone's terms are somewhat different. So I wanted to start just by talking about some of the common terms that will come up in discussions of climate. So weather versus climate. You can think of weather as sort of what's happening today or what's happening in the short term. So weather is happening over the next couple of days. Climate is just the statistics of weather. It's weather aggregated over a longer period of time. And there are, as everyone is aware, a large number of variables that are commonly measured and reported, say, in the weather report. And values of those variables respond to what's on the ground. They respond to topography, so it gets colder and often wetter at higher elevations, responds to the plant communities, responds to the soils, what have you. So all of these things are feedback loops. And then it's also important, especially when thinking about sort of modeled climate, that the way in which variables are measured and the ease of projecting them in space or time really varies from variable to variable. And so climate data, you can think about a weather station, you're getting point level data right there. You know what's happening right there at that particular location. It's fairly common, even in real time, to try to interpolate between those weather stations and to be able to say, this is best knowledge of what's happening in an area where there are no weather stations. Temperature is pretty easy to both to measure and to interpolate. Behavior of temperature, sort of the atmospheric physics of temperature, are fairly well understood. Precipitation is very easy to measure, but it's much more difficult to interpolate from place to place. So you kind of have different inherent uncertainties when you're modeling variables and trying to say what might happen in the future. An effort that our state climate office is leading, the state climate office is embedded within the Oregon Climate Change Research Institute, is working with the National AgriMet Network to obtain resources from the state and federal governments to hopefully augment the AgriMet network. So over a lot of Oregon, as many of you are well aware, there just aren't that many observational weather stations. The stations tend to be in Western Oregon where people are concentrated. But in many of the agricultural areas, especially in Eastern Oregon, there just aren't that many places where weather is being measured on the ground. And therefore our understanding of climate in those areas is less. And in any modeling situation, uncertainty in equals uncertainty out. So the more data you have to work with, the more reliable your models generally tend to be. Climate models in general, a lot of discussion about what's a climate model, what's a global climate model. Global climate models are representing what's known about atmospheric physics. They're basically atmospheric science. So they address how what's happening in the air and on the oceans and on the land are related and what that means. Those are forest resolution projections. The computational intensity of a global climate model is substantial. And so these models make projections for grid cells that are basically 60 miles-ish on a side. And for future projections, climate modelers are making assumptions about human behavior. And in this case, the aspect of human behavior that they're most interested in is emissions of heat trapping gases, often called greenhouse gases. Excuse me. So then there's this concept called downscaling, because a 60-meter or 60-mile grid cell is not necessarily all that helpful. So there's a process called downscaling where climate modelers are in essence saying, what do we know about statistical relations on the ground? What do we know about measurements on the ground? How do those relate to what's happening within a model grid cell? And so basically you can take more detailed on the ground knowledge of topography, of soil conditions, of vegetation, and be able to bring those large area projections down to something that's more amenable to what most people are dealing with every day, to sort of their business decisions every day, to emergency management decisions every day, what have you. But because this is a statistical process, it's informative and it's fairly accurate, but it's not a prediction for a given location. So no climate model is going to tell you what's happening in your field. It's not going to tell you what's happening in this particular park. That's not the intent. And so I think it's really tempting for any of us that know an area well to take one of these downscaled models and say, well, what's being projected for this area here that I know really well, that's not correct. And therefore, I don't have a lot of confidence in the model. That's not the point of the model. Their accuracy is really judged on the basis of what's happening over a much larger area. That's how they're constructed. That's sort of the overall intent. So not predicting what's happening right here, much more for trends. So major change in climate that I want to address in a little bit more detail. No surprise to anyone here, aridity is increasing, and this is westwide, not just in Oregon, although Oregon is part of it. Lots and lots of different ways of dealing with drought. So when people say drought, okay, what kind of drought are you talking about? Kelly Redmond, who at one point was the state climatologist of Oregon, said, you know, drought is just not enough water to do what you want to do with water. That's the most fundamental meaning of drought. But drought is measured in a lot of different ways. So there are measurements of basically how thirsty is the air. There are measurements of how thirsty is the soil. Often those are correlated, but not always. There are a lot of different definitions of drought in terms of what measures of atmospheric and soil moisture are people looking at, what's the application. Drought can be looked at in terms of, you know, there can be multiple years of drought, there can be drought in one season, there can be drought that comes up, flash drought comes up really quickly and often goes away pretty quickly. So this is just to say, it's sometimes useful to say what measure of drought is most meaningful to you, or if someone is talking about drought, what are they talking about? Regardless though of how drought is being measured, or really the time period, drought in Oregon and across most of the Western United States is becoming more frequent, it's becoming longer, and it's becoming more severe. So however you slice and dice it, more drought. What is contributing to drought? So most of us will think, well, duh, how much precipitation is falling? And indeed, it has not been a series of very intensive precipitation years across the state. However, precipitation in Oregon, if you just look at the water year total or the annual total, however you want to measure it, precipitation across the state is fairly stable or even increasing slightly, and is projected to continue increasing slightly or being fairly consistent. So it's not that in the aggregate, we're getting less water, but the timing of when water is showing up is changing. So we're getting often fewer winter storms, but heavier winter storms. Those atmospheric rivers that we tend to get coming in from the west are tending to be more intense. We're getting less precipitation in summer. Summer's dry anyway, but we're getting even less precipitation in summer. Because the air is getting warmer, more of our precipitation is coming as rain and less as snow. And this is a really big deal. Because we're not getting as much snow, we're basically getting flashier precipitation, we're getting earlier peak runoff, we're getting fewer days with snow cover, and all of you intuit the meaning of that for agriculture better than I do. But that's a really big deal. So what else is going on? I just mentioned temperature. For a given amount of water, if the temperature is higher, that water is going to go away faster. So in Oregon, temperature has increased by several degrees Fahrenheit since the turn of the 20th century. Depending on the emission scenario, we're looking at an annual average increase of another 4 to 8 degrees by the end of this century. We're getting warmer nights, and that affects firefighting, that affects agriculture, that affects public health. So it's getting warmer in all seasons, but the greatest increases are in summer. So in addition to that change in mean, we're also getting changes in heat waves. Whatever is hot to you, there are more days like that in the future, and it's hotter on those days. So basically every measure of heat is increasing across the state. One of the ways in which that may manifest for agriculture, in climate world, you'll often hear people talking about pollen and saying that as temperatures increase, pollen seasons are becoming longer, there's going to be more pollen. This is often discussed in terms of public health, in terms of effects on seasonal allergies. But there is, and I would be really interested to hear what people in this meeting are experiencing. More, not as much in the peer-reviewed literature yet, but more and more discussion that that while, say, non-native invasive species, while their pollen is increasing, pollen in the context of agriculture may be getting nailed. So, there are these instances where pollen, especially in some of the warmer and drier parts of the United States and Canada, basically pollen is getting cooked. And this has ramifications not only for actually, well, they're related, for growing crops, but also for bees that are pollinating crops, both native and honeybees. So basically the sex ratio of bees may change if pollen is getting cooked. It takes more nutrients to grow a female bee than a male bee. So there's some discussion that the sex ratios may become more male skewed if there's less pollen available to bees that are pollinating crops. Additional contributors: wind speed, solar radiation, humidity. So basically aridity is more than just the amount of precipitation that we're getting. One of the major effects of aridity, aridity basically being the inverse of water availability, is a change in wildfire risk and a change in wildfire size. So wildfires are like, when there's a spark, wildfires are likely to ignite when you have high temperatures and high aridity and high winds. And the number of large fires is increasing more than the number of small fires. Also, the elevation of wildfires is increasing. I'm not just talking about fires in forested areas, but fires in dry areas across the western, or in sagebrush areas, shrub areas, grass areas. So it's not just, wildfire is not synonymous with forest fire. People often are asking about wind. Wind patterns are not projected to change very little, if at all, across Oregon. But what's happening is when we have strong winds, especially those strong east winds, it's becoming more likely that when those winds happen, it's going to coincide with high temperatures and high aridity. So even if we're holding winds stable, which it looks like is going to happen in the future, we're getting higher heat and higher aridity. And so the likelihood of wildfires is increasing. And along with that comes likelihood of a greater number of days with high concentrations of smoke or of any component of smoke, especially fine particulate matter, and higher concentrations of fine particulates on those days. So obviously that affects public health. It affects especially outdoor workers. More and more people are concerned about this. Those of you that are working with extension, or maybe just what people are asking in your communities, more and more people are saying, what do I do with agricultural products? What do I do in my own garden when there is smoke? How is that going to affect my consumption? How's that going to affect my crop growth? And there's quite a bit of work going on now about effects of smoke on wine grapes, or from my understanding, less the grapes and more what's this going to mean in terms of the quality of wine when the wine is processed for drinking. A couple of resources out there that if you're not already aware of have, I think, really good and really accessible information on what is happening with drought and aridity. One of them is the National Integrated Drought Information System. I finally can say that without thinking about it too hard. It's taken 2 years. So NITIS is the acronym on that. They put out real-time, often monthly updates, especially when drought is ongoing, of sort of what's happening in different sectors. And we're just sort of the moderate term projections suggest drought is going to increase or decrease over the Pacific Northwest in the sort of moderate term. So several months often. Great source. They have webinars, they have bulletins. Go to their website if you are interested and are not already aware of it. Another great resource is something called the Climate Toolbox. This is sort of a do-it-yourself resource for being able to look at both real-time and historic and also projected future metrics. Some of them are basic variables like temperature and precipitation. There are metrics associated with wildfire risk. There are also metrics that are particularly associated with agriculture. This is, I think, a pretty easy to use website. It's gone through a lot of usability evaluations. There are a lot of different ways that you can display the data. And if you get totally stuck, there are humans. And if you send them an email through the website, they will respond to you and help you troubleshoot whatever it is that, that you're trying to deal with. And it's not a huge team of humans, it's a small team of humans, and they will get back to you rapidly. And I will put in a pitch. There are a number of sort of community observer programs now that are trying to get at precipitation, especially in the regions where there are few weather stations. So there's the Community Snow Observation Network, there's Mountain Rain or Snow. If you're more of an everyday type of person, there's CocoRa's. But there are a lot of programs that are trying to get information on precipitation, especially in areas with few weather stations, and especially in areas where the elevation of the snow to rain transition may be changing as temperatures continue to increase. So these are super easy if you're out recreating or you're out working in the fields or what have you. You basically can just, even if you are not connected to, if you don't have cell reception at the time, you're basically taking a coordinate and saying, for something like this one, it's raining, it's snowing, or it's mixed, that's it. And something that simple can be incredibly helpful to people that are trying to say what's going to happen with precipitation and with aridity in the future. So that's all I have. Thank you very much for the opportunity to meet with you today.
Great, thank you, Erica. We are a couple minutes ahead of schedule, so I think we can have time for one question. It looks like there might be one that got entered into the chat.
Yeah.
So let's see. You want to read it, Megan?
Yeah, or Michael, if you want to unmute yourself and ask your question, that would work as well. If not, I can read it. So in a time of increasing drought, how important is it to increase the capacity of soil to absorb more water by improving soil health through use of no-till, cover crops, and other regenerative or conservation-based farming and ranching methods?
So I would answer that in two pieces. One is that doing whatever one can to increase the water holding capacity and water absorbing capacity of soil is extremely important. That's kind of a no-brainer. Also important to evaluate the extent to which different practices are doing that. So all of these practices that you mentioned, no-till, cover crops, other regenerative methods, they have a lot of benefits. They're not all evaluated with respect to a particular benefit in every location. So if you're interested in using cover crops, saying, well, you know, to what extent are they increasing the water holding capacity of your soil? Depends on soil type, depends on a lot of things. Is it doing what you want it to do? And are there other benefits that you might want to pursue, even if it's not doing that thing? But any of these practices, they're going to have some benefits, whether they're going to increase water holding in a particular place, time, set of circumstances. Gathering information on that is extremely helpful to say, is it doing what you want it to do?
Great, thank you, Erica. So Hannah, do you want to go ahead and pull up your presentation?
Sure. All right. Well, thanks a lot. Thanks, Erica. That was really fun. And Erica and I are colleagues at on campus at OSU, so it's fun to see. It's great. It's really great for geography for us both to be here in the real world, like interacting with Oregonians and farmers and ranchers, and really appreciate that privilege, that opportunity to step out of the ivory tower. So I appreciate being asked to share some of my research on farmers and ranchers' experiences transitioning from conventional to regenerative ag. And Ashley asked me to talk about some of the factors that influence producers' decision-making about climate resilience. And since that's our central theme in this series of workshops, I thought I'd start with some terminology. So from an academic point of view, climate resilience can be thought of as an approach to climate change adaptation that entails identifying and fostering characteristics that allow individuals, communities, and systems to effectively respond, recover, and return to normal functioning following a climate-related event, and to respond better to future impacts. And then in the materials for this workshop, ORCAN defines climate resilience similarly as a set of practices that reduce risks from extreme weather events, store more carbon in the soil, and work for a farmer's bottom line. So with those in mind, I'm going to transition to these two concepts, climate smart ag and regenerative ag. They've both been thrown around a lot recently as ways to promote climate resilience. So climate smart ag is a term coined originally by the UN FAO and refers to practices that increase adaptive capacity, mitigate climate change, and increase food security. Regenerative agriculture is climate smart, but I think it also puts a higher value on a higher explicit value on soil health and functional ecosystem processes. And key principles for regenerative ag include leveraging natural processes rather than using agrochemicals, for example, to increase adaptive capacity, and also adopting a systems thinking approach to food and fiber production. And then many, but certainly not all, regenerative farmers and ranchers practice holistic management, which includes holistic decision-making and holistic planned grazing. And there are a lot of definitions of regenerative ag floating around these days, but I've defined it as a set of principles and practices that concerns itself with restoring and maintaining soil health and fertility and biodiversity, watershed health, and soil water retention, all while improving ecological and economic resilience. And I would say that regenerative ag goes beyond sustainable agriculture because it's not just sustaining a system that may not be working optimally, it's regenerating the system so that it's on an upward trajectory of ecosystem functionality and health. And here are some of the main practices I've identified through my research, which you should know is focused more on ranching than farming. So if these seem a little ranch centric, that's why. You'll be hearing a little more about some of these practices from Cory later on this morning. And they include daily monitoring, for some people, holistic planned grazing, so usually some kind of planned grazing, rotational grazing, adaptive multi-paddock grazing, low stress stockmanship, because with this planned grazing, you move the cattle much more frequently to avoid overgrazing and to regenerate the soil. So you need to learn easier and more efficient ways to work with the animals. So that's a whole new approach to animal husbandry for many people. Involves foregoing or at least reducing chemicals for many, composting, cover crops, tolerating weeds, facilitating perennialization, which refers to promoting native perennials instead of non-native annuals like alfalfa. And I just want to emphasize how different these principles and practices are from the conventional industrial model. Taking these on involves a pretty steep learning curve for most people. And so therefore a lot of humility and willingness to try new things and to sometimes fail. So the research I did on this topic was originally funded by the US Forest Service. They were interested in what factors might incentivize ranchers in the US West to engage in climate smart regenerative practices. And then we later extended the research to include sheep and beef farmers in Australia. And in Australia, they don't use the term ranchers. So I kind of use farmers and ranchers interchangeably, but I'm talking about people who produce livestock for my research. And in Australia, there's a lot of interest in regenerative ag and the potential for a carbon market, and also a lot of experienced high profile practitioners there. So our two broad questions going into the research were, what factors influence farmers' adoption of climate smart regenerative ag? And what are some ways to support farmers' transformation and persistence on the regenerative path? And we originally hypothesized that carbon markets and other kinds of financial incentives would be really important motivators for a transition. So for our methods, we sought out farmers and ranchers who were already engaged in regenerative ag and who may have participated in some kind of carbon market scheme. And so those methods were, our methods were qualitative, and they included interviews with 23 ranchers from the US West who had participated in the Chicago Climate Exchange's voluntary carbon market and actually earned carbon credits. And then 21 sheep and beef farmers in New South Wales, Australia, who were actively involved in regenerative ag and who were at least aware of Australia's carbon farming initiative. And then I also interviewed educators and consultants who train farmers and ranchers in regenerative ag and support them through the transition process, like many of you, because they have a unique perspective on what motivates their clients or their students and what challenges them. So then I transcribed and coded all the interviews. I picked exemplar quotes to represent the patterns I identified, some of which I'll be sharing with you. And I also engaged in participant observation, meaning I attended meetings related to regenerative ag in the US and Australia. I attended an 8-week holistic management course in Australia and observed group dynamics, took notes, and then of course document analysis is another standard form of qualitative research. And a key finding in both places was that none of the producers had switched to carbon-friendly practices because of carbon payments. They were all already engaged in these practices for a whole different set of reasons. And as you can see from this quote here from a rancher in Montana, he says, "We're improving our agricultural system irrespective of the carbon market. We're doing those practices not because we expect to make money from selling carbon, but because that's the way to better sustain ourselves here, by having more cover and capturing more moisture and taking advantage of what we can in an arid environment." The primary benefits I heard about from all the ranchers and farmers I talked to really had to do with reduced vulnerability to drought due to improved soil health. And this Aussie farmer says, you've got no control over actual rainfall, but you have full control over effective rainfall, as the person who just asked a question was pointing out. If you've got bare ground and you get an inch of rain, most of it's going to run off into the creek. But if you've got full ground cover and all the energy is taken out of the water before it hits the soil surface, it stops the compaction, soaks in, and then the ground cover holds the water there. So we can control that. And interviewees also spoke a lot about better forage for the animals, more profits due to giving up chemicals, and also the improved quality of life just associated with regenerative farming in general. For one of the articles I published with Susan Charnley and Paige Stanley, we proposed that ranchers' decisions to adopt or not adopt regenerative ranching should be seen in the context of the social ecological system in which they operate. So this diagram portrays a rangeland social ecological system with relevant social dynamics on the left and ecological dynamics on the right. So the social dynamics include personal, economic, political, and cultural factors, and ecological dynamics have to do with the mineral cycle, water cycle, energy flows, and community dynamics. And these social and ecological dynamics act as constraints or enablers, influencing ranchers' ability to first understand the system and then to manage the system through adaptive management. And you can see the different suites of benefits along the top with climate change mitigation in the middle, but also importantly, socioeconomic benefits in the upper left and then other ecosystem benefits in the upper right. So socioeconomic benefits that I heard a lot about consistently included increased productivity, reduced inputs and expenses, fewer veterinary expenses, financial well-being, sense of community, sense of right livelihood, and then sometimes payments for ecosystem services for some of them. And then the ecosystem co-benefits include increased soil water holding capacity, increased resilience to droughts and floods, increased plant biodiversity, improved wildlife habitat, and elimination of chemicals. So now I'm going to share with you a few quotes about the importance that understanding the system and knowing how to manage the system play in producers' ability to adopt these practices and become more climate resilient. Some of my most interesting findings came from interviews with consultants who work with the farmers and ranchers to help them transition, which I know many of you do too. This one says, changing the mindset of the farmers is very difficult. They don't believe that nature can take care of feeding the world. It's just that the regenerative system is so different. The concepts are so different that they can't see. We're both looking at the same thing, but from a different perspective. So they can't understand what I'm saying, but I understand what they're saying because I've dealt with that mindset and there's a lot of resistance. And the same consultant goes on to say, one of the biggest aha moments is when they start to see the soil structure change on their property. For example, they'll see that before they could not stick their finger into the soil deeper than 1/2 inch, and now they can go in all the way to their palm. And they start seeing the mycelium forming, and soil aggregation happening and the moisture in the soil from the water seeping in and not running off. And they're like, wow, it's possible, it's amazing. And they look at the improved soil with disbelief, and then they get happy and they get excited. And what I like about this quote is the link between understanding nature and then just the pure joy. They're happy, not just because they're going to be able to grow food without chemicals, but just because nature is cool. So, and I see this excitement and enthusiasm about working with soil as a really underappreciated driver of behavioral change and potentially a powerful leverage point for larger scale social ecological transformation. That kind of those biophilic emotions where people just get excited about connecting with nature and understanding it, being able to work with it. Another consultant talks about the excitement that comes from understanding and interacting with other life forms in the process of producing food and fiber, rather than trying to kill them all. He says, there's nothing more rewarding for farmers than knowing that they're doing a good job when they understand that ecosystem framework. They'll get most excited about fungi. They see strands of fungi, and that's brilliant because they know that's a really good thing. They'll see spiders spinning webs between the tall plants. Now, spiders are a top order predator. If they get lots of spiders, they know there's a lot of things happening that feed the spiders and through that, the soil food web. So they get very excited about digging around and finding worms for the first time and not seeing runoff from their land after a heavy storm, or the runoff that happens is clear, it doesn't have soil in it. They see huge benefits from seeing different types of birds coming in. And I just want to ask you to note the connection between seeing that farmer sees the insects and animals on their land and not having runoff. They see the connection between those two. So they see that by working with nature in collaboration with creatures that they might have killed in the past, this farmer now has better water infiltration and less soil erosion and better water quality. So that's pretty cool. So once they begin to understand the various ecosystem processes, the next challenge is figuring out how to work with these processes and leverage them to achieve their objectives. And this involves a whole new set of skills. And think of the list of practices that I mentioned earlier that Cory is going to go into later. But probably the most important skill for managing the system, in my view, is this multidimensional, multisensory approach to monitoring. And this Oregon rancher points out that the challenge is that, not only can we not see an ecosystem, we can't see a water cycle, we can't see a mineral cycle. So we have to we learn to look for symptoms that are indicators of how well that particular ecosystem process is working. And one Aussie farmer says, it's just constant monitoring because you acknowledge you're going to be wrong. So you need to keep on monitoring. And what would we look for? Soil surface, plants not recovering, plant wilt, anything like that. And then another Oregon rancher says, you have this awareness. You don't just move your cattle, you go look at the ground. So this increased attention to daily monitoring associated with regenerative ag had a big impact on all the producers I spoke with. And one of my most interesting findings was that the rewards associated with working more closely with nature and regular monitoring and constantly learning really act as positive feedbacks that sustain the commitment to regenerative ag, which is important because it's one thing to try something new, but to stick with it is a whole other thing. And I refer to this phenomenon as self-amplifying positive feedbacks. And if you're interested, I can send you the article, which will explain these diagrams in more detail. So, all right, so what does all this mean for our efforts to support producers who are considering a transition? In a nutshell, I'd say that financial and technical support are obviously key, but that what might be less obvious is the need for emotional and psychological support, since it's such a big change for many people. And farmers need a safe space to ask questions, make mistakes, and experiment. And another key finding, and this isn't news to anyone here, is that farmers and ranchers really enjoy learning from each other. So setting up peer-to-peer learning networks will be key. And then finally, how we communicate with farmers and ranchers about climate resilience and climate smart regenerative ag is also key. And you're going to be learning all about that at next week's workshop. We'll be focused on communication. So just to sum up, the main motivators for adoption of regenerative ag seem to be increased resilience to drought and other climate stressors, and then the socioeconomic benefits I mentioned. And then the soil carbon sequestration is not as big of a motivator in my experience, although we'll see with all this money coming down the pike to support climate smart ag, maybe people will see that will be interested in the potential financial benefits. And then decisions regarding adoption really hinge on farmers' ability to understand the system and manage it for desired outcomes. And those both involve a lot of technical training and learning about new tools and processes and practices. But as I've already suggested, that financial and technical support is financial and technical support is necessary, but certainly not sufficient. Oh my gosh, sorry. So I think at the end of the day, the big take-home message is that there's a real need for an integrated, holistic approach to engaging ranchers in transformational, experiential, social learning, including assistance with getting off chemicals, understanding the system, and managing the system. One of my interviewees said it generally takes about 3 years to make the transition, with a lot of hand-holding along the way. So that's an important thing to think about, 3 years. So my research also highlights the important role of networks and communities of practice and peer support, social learning, and something I didn't talk about today, but mentioned last year that got a lot of interest was the potential for microscope groups to engage farmers in ongoing learning about the subterranean. So that if there's people interested in that, it'd be fun to continue to explore those possibilities. So with that, I will wrap up, invite you to get in touch with me if you'd like to discuss these topics further, and or if you'd like me to send you any of the articles that I've published that I was citing from here. Yeah, so thank you so much for your time, and look forward to interacting with you all over the next few weeks. Thanks.
Great, thank you, Hannah. And so we do have a couple of minutes for questions for both Erica and Hannah. You are welcome to raise your hand to ask a question, or you can ask a question in the chat. It looks like we already have a couple from the chat, so we'll start maybe with one of those. But if you'd also like to raise your hand, you just go to the little reactions button on the bottom, or you can raise your hand in real time. I saw you, Deborah, and and you can ask a question. So let's start with Deborah, and then maybe we'll take a question from the chat. So Megan, I'll let you pick one from there.
Okay. I'm Donna. This is Deborah, but mine is not up there. So yeah, we work with a conventional farmer right now on our property, and we have we're trying to work with him around regenerative practices, and he's a loner out here in the Willamette Valley. He does things unconventionally because we've asked him to. Is there a way, is there other ways that we can support him? I mean, he rents our land, he leases our land, and he leaves a lot of money on the field because we've asked him to do that, like his straw and his, that he normally would have taken off and baled on his grass seed and his wheat crop. And we want to do better, and we could do it some financially as well, but we want him to be able to experiment with that on our property. And is there any, first of all, is there any assistance for that in conservation realms, or, you know, what can we do to help that, to keep that going?
Well, you've come to the right place, that's for sure. Because I would say, for starters, have him join ORCAN and talk to Ashley, and she can get him hooked up with all kinds of cool, you know, compadre farmers in Oregon. And then there's other networks too that are more national and regional. The Savory Institute has a whole system of hubs all over the country, around the world, actually. And there's there's lots of networks out there and resources. And then as far as the financial support, again, you've come to the right place, because we have Cory here from NRCS, who, I don't know, at some point she might talk about all these new programs that, well, all this new funding that's coming in. You know, that the Inflation Reduction Act allocated $20 billion to support climate smart agriculture through existing NRCS programs. So we'll be seeing, hopefully we'll be seeing some pretty big changes in the next couple of years. I don't know, I'd love to hear what Cory thinks about that. But yeah, now is really an exciting time to be getting into this, because there is the support from our federal government, and there's actually dollars behind that support. And then you've got organizations like ORCAN that are there for that kind of the hand-holding and the moral support and the peer-to-peer learning. But if Ashley wants to chime in too about that, the support that's available for an Oregon farmer.
Well, I'll just say that we'll definitely talk a little bit more about financial support in the 4th workshop. I think there's some interesting complexities with your situation, with you all being the landowners and then having them lease that property. But I think there's lots of creative solutions, and just want to offer up myself and then other folks who are in this room who are also experts in the space to chime in the chat with additional ideas. So I look forward to a longer conversation.
Great. Thank you.
Cool, and I think we have time for one question from the chat. So I'm going to pick out Nancy's question here, and then maybe Hannah, you can respond to the others in a chat response after this, or maybe in a follow-up at some point. But Nancy is wondering if there's what the impact is on costs for transitioning to regenerative systems. Do farmers also see higher yields? And what is the cost at the front end? And then I kind of want to add to that, when we think about incentive programs, if you got any good information on types of financial assistance that producers found most helpful.
Yeah, I think, well, I'm a social scientist, so one of the interesting things that I discovered was that, so keep in mind, the people I interviewed were all kind of veteran regenerative practitioners. They'd been doing it for a long time. They were already, well established and successful, and they were telling me their stories of transformation and how they went from conventional to regenerative and some of the bumps along the way and how they changed. And one big thing is this kind of shift in the way they think about profits. Many of them talked about having to switch from a focus on yield to a focus on profits. And they pretty much all were saying, yes, I'm more profitable, but for many, their yield had gone down. And the reason they were more profitable for almost always was because they'd given up chemicals. They'd figured out some way to give up chemicals, which is such a huge part of the budget. A lot of them, for a lot of them, what drove them into this to begin with was that they couldn't keep up with the cost of all the agrochemicals, the synthetic fertilizers and the pesticides and herbicides, and they had to find a different way to do it. And then once they found this different way, they were like, oh, well, I'm saving all this money, and maybe I'm not producing quite as much, but I'm happier and I'm profiting. So that's my take on it. And I'm not the best one to talk about the bigger picture economics of regenerative ag, but there are a lot of people in this room who probably would be better. So, and then, yeah, again, as far as the financial incentives, it sounds like there'll be a whole session in the 4th week focused on that.
Thank you all so much. I really appreciate these presentations, and I'd love to keep up with the Q&A in the regional breakout rooms. We're about to shift into that space. I'm going to put in the chat a place for you to find some kind of discussion guides for these regional breakout groups that are going to happen. And one last thing before I transition there, we had, for those of you who work in rangelands and are really concerned about climate change impacts on rangelands, we had Anna Marr from the Northwest Climate Hub do a great presentation for us. She had a conflict today, so she couldn't make it, but we'll have that posted online if you want to hear more about climate impacts to rangelands and adaptation strategies. So we are going to head into some regional breakout rooms because last year, this was one of the most successful parts of our training. And the idea is to really create communities of practice at the regional space and develop regionally specific information and identify gaps together as a group. We've got a lot of folks on the call who register or work more in the statewide realm. So we're going to have plenty of space for you as well. And let's see how it's going to work. In a minute, you're going to be able to pick which breakout room you go into, and I'll show you a slide to kind of guide you through that a little bit more. And we've created some worksheets to guide the discussions in the breakout rooms and as a space for us to begin to document our needs. So I just sent in the chat a link to the agenda, which in there you'll have the worksheets linked as well. And then I think Megan in a minute will put a link to the folder, but just want to acknowledge sometimes things get confusing when you go into breakout rooms as to how to access information. So feel free to click on that link now and be able to get to those documents. So what I'm going to do is open up one of these worksheets really quickly and then share my screen with everybody. I'll just take a moment here. Okay, can you all see that? So when you go into your breakout room, it'd be great if you could identify a facilitator and a note taker. Hopefully we'll have about 9 people max in each room. And you're going to introduce yourself again to create this community of practice really briefly. And then we'll start kind of trying to frame some ideas of what's happening in your region, starting with context. What are the cropping systems? What are the existing climate threats? And then we'll go into some known solutions. What don't we know? What are some potential research questions? And then if we have time, we're going to be cutting it a little close, have folks begin to reflect on what what's one solution that makes you feel really optimistic and what's one situation that makes you nervous. So that's going to be just a quick snapshot of the flow. And then I'm going to just pop open a slide that shows the regional breakout rooms so that you guys have a sense of what I'm talking about. I'll share my screen. Okay, let me just pop this open. All right, so these are sort of the different breakout rooms that we have. We've got a lot of people in a couple different groups, so we'll break you up by your first name. So if you're in the Oregon statewide zone and your first names go A through D, you would pick group 1, for example. Once we go into the breakout rooms, we might do a little bit of shuffling so that there's, max 9 people in each room. So thank you for your patience as we go in and out of these breakout rooms. Let's see. And with that, Emmerich, are you able to pull up the breakout rooms for folks to go in there for these discussions?
I'm going to open these all up and you should be able to make your selection. I'll pause the recording now.
And we're getting back into the recording. And if anyone wants to share anything back out in the chat reflecting on that breakout group experience, I'd love to see that. And I'm also really excited to give space to Cory Owens to share her presentation for us as well. So I'm going to pass it off to Jessie to help us transition.
Thanks, Ashley. So just very quickly wanted to introduce Cory Owens. She is a 21-year veteran of the Natural Resources Conservation Service and has served as the Oregon Assistant State Conservationist for Partnerships since June of 2021. Prior to this current position, she served as the NRCS Oregon State Soil Scientist. And as she mentioned in her introduction, she's the NRCS Northwest Climate Hub co-lead. Cory earned her bachelor's degree in crop and soil science from Oregon State and holds an MS in soil science from the University of California, Davis. So again, we'll take questions after Cory's presentations. If you think of questions during the presentation, go ahead and type them into chat and I'll turn it over to Cory.
Thank you, Jessie. So excited to be able to be here today and see the second year of this workshop. I'm really excited about our format. I'm really excited about the interaction. I just left my breakout room and I could have used another 15, 20 minutes for sure. Ashley, we had just started to get some good conversation going. So I'm going to talk to you guys today about managing climate risk with soil conservation. This is a presentation similar kind of to what Eric did that was done last year with some updates and some different refreshed ideas because it's been a year. And I definitely am excited because we're going to be able to do a little recap and I have Emmerich is going to help me amazingly. I've got a bunch of handouts and links that as I talk, they're going to put those in the chat for us and that'll be resources that you'll have available to you. Then I'm going to talk about mitigation and adaptation because Hannah did such a lovely definition of resilience. That was awesome. A little bit of a deep dive into some practices. Going to mention economics and we're going to just briefly touch programs. And maybe I'll be able to speak a little bit to some of those questions about we're calling it the IRA, the Inflation Reduction Act. So as a good trainer, I am starting with what I want you all to take away from the next half an hour together. And I really thought about these key takeaways and they really kind of set up all the information that I'm going to give you is going to support these. And the first and most important one, as agricultural practitioners, as people who are working in and around the state and are familiar with conservation and ecosystem function and the work of conservationists, the biggest thing I want you to know is when we start talking about climate smart things, that these are our familiar conservation practices. They're also climate smart. In the world of ag and natural resources conservation, there isn't like some magic new thing someone has come up with that I've noticed yet that's like specific to climate. These are all putting the work that we're already doing and have done for years and decades into a climate context and understanding better how those practices have these co-benefits. And so a climate perspective on these practices highlights those co-benefits. So I want to talk about that because that can really help us with the conversations we have with the farmers and ranchers and foresters that we work with. It can kind of help put the filter on that it'll help us as we're talking to them, find the way that's going to resonate with them the most so they can think about if they want to implement any of these things. Also want you all to know that there are a lot of decision support tools to help inform and make the mitigation and adaptation choices that these practices support. I'll just be able to touch the surface of that, but I'll give you a lot of resources on where to go for more. Also, adaptation is a continuous process. It's not a one and done. There's not a silver bullet. If you've been to any kind of training before, you've heard that said, and that is because doing good conservation work is not hard and it doesn't stop. And that's something that I think as we face this climate challenge, it reinforces that even more. And also something that came up in the kind of where our small group ended and was, reinforced by Hannah, like economics are an important factor. They're one of the important factors, and cost and benefits must be weighed. And again, there's not one recipe for success. And there are programs that exist now and programs that are coming to support climate smart agriculture. And it could be programs that you are familiar with that put a climate spin on what they're doing, or it could be new programs that take what you've been used to doing and making the emphasis on the way that the climate benefits of those practices. So quick recap, we had Erica give us a lovely introduction to what's happening across Oregon for climate. So Emmerich, this is the Applying Soil Health Management Systems Climate Risk handout. That would be great to have there, but wanted to just reiterate that we're looking to see with projected temperature increases, crop yields will be impacted, but maybe it's good or maybe it's bad. It depends on the crop, because some crops are going to do better with warmer nights and do better with higher heat. We do expect increased pest pressures. You can just universally, we can expect that with more heat and we're going to have more pressure from pest disease and weeds. And then longer growing seasons. And again, a longer growing season may be good or bad depending on the crop and depending on where you are. So those are where you can start becoming maybe a problem solver and think about, okay, knowing that, where can I start to think about adaptive options? And then again, putting it into projected impacts of precipitation extremes. As Erica said, decreased snowpack, can expect crop and livestock stress if we're not ready to handle having a decreased snowpack, and then increased fallow production. If there's not enough water to grow stuff in an irrigation system, then what are you going to do with that land? You're going to take the water that you have and irrigate what you can, and then you have stuff that's fallowed. So, we have to think about the implications of more fallow land, and of course, increased fire risk. That's kind of universally understood. We've been living with that for several years now. So I would love everybody to raise your hand if you have seen the 4 principles of soil health. Many of you you've probably heard me talk about the principles of soil health. Lots of people are raising their hands. It might not have been me, someone from NRCS, someone from a soil water conservation district. The 4 principles of soil health is probably actually one of the coolest things in my career, my 21 years with NRCS, that I saw that NRCS came up with, because it's such a handy framework to talk about high functioning soil ecosystems, because that's what soil health is. It's all about creating high functioning ecosystems and making sure that we as practitioners have a context in which we can have these conversations with folks about those who want to increase their soil health and their ecosystem function. So we've got maximizing continuous living roots, and there's a list of cropland practices that you can do that with: cover crops, relay cropping. Maximizing biodiversity, and there's a picture of a cow there on purpose, because a lot of people take livestock and have it as a 5th principle, but we, depending on which framework we're sticking with for now, we consider adding livestock to a system is increasing the overall biodiversity of that system. So that's crop rotation, rotational grazing. It's adding diversity in space and time to what you're growing. Minimizing disturbance is great. That one is all about understanding that soil is an ecosystem that builds a structure with aggregate stability. Some of Hannah's great slides talked about them, seeing the soil aggregate, and that's because increased organic matter and microbial and soil food web activity is creating the mycelium and the soil carbon glues that hold soil aggregates together. Well, if you disturb soil, you bust all that apart. So it's kind of this balance of understanding what your disturbance activity does and try to be mindful when you're disturbing your soil. And then maximizing soil cover. Hannah couldn't have set this up better when she had the quote from the person saying it, the soil cover will intercept that raindrop speed and velocity. And so it, instead of just running off, it kind of hits that pillow of cover and then it absorbs into the ground and is available for plant and organism use. So thanks, Hannah. We didn't even plan it. That's great. All right, so talking about soil health principles, because now I want to put the idea of soil health into the context of mitigation and adaptation. And I'm going to also define some terms. So adaptation and mitigation in a soil health context. So when we think about mitigation is protection of carbon that's in place, and sequestration is putting carbon from the atmosphere somewhere not in the atmosphere. And in this case, it's the soil. So from a soil health context, mitigation is keeping high functioning soil ecosystems intact. So if it's already working great, let's keep it that way, it's protected. And then let's think about soil health practices that not only give you high ecosystem function, but also build carbon along the way. And you know, something that Erica mentioned is like being specific about, you know, if you're growing cover crops, are you increasing water holding capacity? Well, it depends, because some cover crops are putting down huge root biomasses that will store carbon and some cover crops do not. They're still getting benefits, but it might not be a sequestration necessarily benefit. It might be a nutrient cycling benefit or a protection benefit or a weed suppression benefit. So you can think about some of these practices in a way that is more climate focused, but also hit some of these other things. And I do have this little asterisk here about being cognizant of natural carbon saturation levels. Not every soil is the same, shocker, right? So you want to think about sequestering carbon in the context of your soil that you're working with capacity to store that carbon. And we also need to think about where within a soil profile, soils are vertical profiles, where in that profile is the opportunity to store carbon. We often just do a lot of analysis and fertility in the top of the soil, in the topsoil, but a lot of our soils have a stronger access to a pool and long-term storage of carbon in the subsoil. So that's how do you get the carbon down into the subsoil for that long-term storage, and that can have a lot of conversations about ways you can do that with different crops. And then adaptation. So adaptation is building and increasing soil ecosystem function in this changing environment that we're working in. So we want to match our soil health practices to fit the current climate and the anticipated climate changes. So mitigation, protection, sequestration, adaptation is building and increasing soil ecosystem function with knowing what's going on. So there's this lovely paper that was published in Nature called Climate Smart Soils. And none of you can read this graph, but I wanted to show you what I'm going to show you next actually came from the paper. So I've taken subsets of this, and this is a whole paper that's dedicated to describing soils as a way to mitigate, so protection or sequestration, mitigate greenhouse gases, and using soils as a base and foundation of mitigation practices for greenhouse gases. But also what this paper does in a really elegant way is it talks about the practice co-benefits. So on the left, on the yellow baseline condition, there's just like 4 potential states of your soil. You know, nutrient deficiency, bare fallow, excessive fertilizer use, intensive tillage. They call these mitigation practices. We might call them, you know, soil health practices. So, all right, if I've got intensive tillage, I'm going to minimize my tillage. I'm going to move to a no-till system or a strip-till system, or I'm going to change my implement. Right, a lot can be said just for looking at the machine, the steel that you're putting in the ground, and making adjustments to that. And then I will, by mitigating that or by addressing that intensive tillage, then I'm going to get a high functioning soil ecosystem, which this paper says is also going to start capturing greenhouse gases, high capacity greenhouse gas mitigation on croplands, but then it's also going to have these co-benefits, these practice co-benefits. So for intensive tillage, and if you reduce your tillage, you're going to have decreased soil erosion. With decreased soil erosion, of course, comes increased water quality, and of course, increased overall soil ecosystem function, which is we consider a healthy, you know, a more healthy soil ecosystem. This paper also, in that big graph that I showed you, assigns kind of a relative cost estimation of how expensive it is to apply some of these mitigation practices. The four that I chose just happen to be some of the lower cost ones. They do have much more high cost ones when you're talking about like wetlands and that sort of thing. So it certainly puts into context the capacity and the potential for soils to be able to, look at soils from a greenhouse gas mitigation context. And what can we do to start putting some numbers on that? And this is where I wanted to quickly introduce COMET. COMET is the Carbon and Greenhouse Gas Evaluation Tool. It is an NRCS tool in collaboration with Colorado State. And it really is providing a generalized estimate of greenhouse gas impact for conservation practice, for NRCS conservation practices. And it's intended for planning purposes. And if you were among any of the entities that did apply for that big USDA $1 billion climate commodities grant, they used COMET as their metric for tell us how much greenhouse gas, mitigation that your ideas and your grant would, your project would, result in. It doesn't work great for every single practice, not every single one's in there, but it's a good place to start. And I just want to flag it up as a place where you can go, even if you're not running COMET specifically, you can get a lot of information out of COMET, and it'll be something that I bring up when I talk about the practices. And Emmerich, thank you for posting the Nature paper. It's actually not a very long paper. It's a nice fun read. So if you haven't read a science paper in a while, I recommend that one. So they'll practice deep dive. And I liked that Hannah had the UN there to define climate smart. When I went on and like, okay, there is no definitive list of climate smart agricultural practices. The state of Oregon's got a list, NRCS has a list, the country of Botswana has a list, the Food and Agricultural Organization of the United Nations has a list, right? The World Bank has a list. They're not that dissimilar, but they're not identical. And I say, let's get less caught up in what the official list is of climate smart agriculture and think more about what are the conservation practices that I know of that I can expect some, climate co-benefits from. So I won't bore you all with a list, though they're there if you want to find them. So I'm going to start with cover cropping. I'm going to highlight two. So why is cover cropping considered a climate smart practice? And that is because with cover cropping, you can maintain or increase soil health and organic matter content. That is a known established result of a cover crop system. And notice it says maintain. So that goes to the protection of carbon that's already in there that from a protection standpoint, and then sequestration is increasing that organic matter content. So that is why it's considered climate smart. It hits that greenhouse gas emission. And then if we want to know more about how cover cropping is able to sequester greenhouse gases and what to relatively expect in a drier, semi-arid versus a moist or humid climate for cover crop, you have, this is out of, again, COMET for carbon dioxide, nitrous oxide, and methane reported in carbon dioxide equivalents acres per year. There's a whole hour we could spend on the science of units in climate science, which we won't. You guys can Google that one. I'm sure there's a great talk on it or a presentation somewhere. But this just gives you a roundabout thing. So if you are a practitioner who is being asked to quantify some of this work and you're doing cover cropping, there are some resources out there. So let's put it into context. How is cover cropping really climate smart? Well, it's because it hits all of the things that we've talked about so far. Again, mitigation, it can result in the protection and storage of, carbon in the soil. So we can take, plants are amazing, photosynthesis is amazing, get that carbon dioxide out of the atmosphere and pump it down in the soil where it wants to be, where it was a long time ago. And then adaptation. So this speaks to what Erica talked about in some of the ways that she answered her questions, and also Hannah, is you can start to choose cover crops that work in changing precipitation and temperature regimes. So we can look at those tools, we can know what we're expecting to happen, and we can start to seek out cultivars and species that are able to be ready to handle the climate, the temperature and the precip that we're going to expect and that we're expecting now. And then resiliency. This is Hannah's big picture definition. So higher functioning soils across the landscape are going to buffer against extreme weather events and have more socioeconomic stability if we have a good high functioning soil ecosystem around and a resiliency around that. And cover cropping can be, it's a great practice. It is as big as cover cropping 1,000-acre fields as a cover crop in your garden. It's very scalable, and that's one of the reasons why it's often touted as a great climate smart practice. So how do you know which cover crop to grow? I saw that Nick mentioned in the chat the Western Cover Crop Alliance. So excited that we have up and running Cover Crop Alliance for the West now. We were one of the last ones to form in the country. And that Western Cover Crop Alliance, along with all the other alliances, I believe there are 4, there might be 5, Nick can speak to that, in the country, are all working together with the Agricultural Research Service, part of USDA, on a big, pretty fabulous national cover crop tool. Right now, what we have in the Pacific Northwest is a cover crop selection tool. It's old, it's a little clunky, it's an oldie, but it's a goodie. If you can download it and work your way through an Access database, it still will give you good answers. And the reason that it exists is because Oregon grows crops in precip zones way lower than most people would expect. So most of the years ago, the unlike cover crop calculators that were available commercially or through research did not go down to like a 6 to 9 inch precip zone. And of course, people think, because they don't even think that people are growing anything in that low of a precip zone, but in our wheat fallow rotations, we are. So it's a way to be able to use the Oregon, and that's the Pacific Northwest, so Oregon, Idaho, Washington, specific climate information to be able to, make help people decide what cover crop to use. So the information that's the backbone of the cover crop selection tool is supposed to get into the big national tool. So we shouldn't be losing any of this functionality, but I haven't seen the framework for that. All right, so hedgerow and riparian planting. So shifting from a cropland practice to a different habitat, more ecosystem type practice. So why are riparian plantings and hedgerow plantings considered climate smart? Because both of them increase carbon storage, not only in the plant biomass, but in their root structures down into the soil. So similar to cover crops, you can go to Comet and you can get a number, a general number for what the greenhouse gas emission reduction expectation is of these two practices. And again, riparian and hedgerow planting can be considered climate smart because they hit all 3 of the main targets. So mitigation, obviously you're protecting and storing carbon by putting carbon into trees and biomass in the soil. And that adaptation, choosing trees and shrubs that will thrive in the new temperature and precipitation patterns. Similar to cover cropping, we can shift what we plant and shift what we plan based on what we expect. And of course, resiliency across the landscape, a landscape that has a lot of biodiversity is going to increase landscape ecosystem services. So that's why we consider riparian and hedgerow plantings climate smart. Here's an example of a tool that can help you make a adaptive riparian or hedgerow planting decision. This is the seed lot selection tool, and it looks at climate variables that are important for plant growth and can answer the question, where do I find adapted plants? And it goes both ways. It can give a planting for a given planting site, for a place where you want to put in your riparian planting. You can say which seed lot is well adapted today or in the future. So we say, I'm going to plant these in Douglas County today. Where seed lot, probably in Northern California, would have seeds, plant materials that would work well in the climate that I'm expecting. And then given a seed lot, where is it well adapted today? So this is my seed lot. Where today can I sell my seeds that that I'm producing in a seed lot? So those are 2 practices. If you want to know more, Comet has a great kind of library of what NRCS is considering climate smart practices, and they have this fun little graphic about how the greenhouse gas benefits, so conservation cover is considered dark green for greenhouse gas benefits. I cannot emphasize enough how excellent the Northwest Climate Hub tools library is. It's just like, people are like, we need a library of tools. I'm like, no, you don't. We have one. The Climate Hub has the best library of tools, and it's curated and they're kept up to date. It really is such a great place to go and look for things. They've got the seed lot selection tool I mentioned, the Pacific Northwest Biochar Atlas. They've got Adaptation Partners Climate Change Adaptation Library. I mean, this is they have like 4 pages of tools. So I can't express enough to you, like your organization does not need to create a tool library. Your organization just needs to link to the Climate Hub's tool library. And these aren't all federally supported, as these, like the biochar is coming through OSU. So there's a lot of, it's not just federal tools, it's everything that's out there that makes sense and works in the Northwest region is usually there. So quickly want to talk about challenges to adaptation, because everything I just said sounds great. Awesome, we should do that. We should think about what's happening and we should make decisions. All right, but it's hard. Just like Hannah talked about, as those folks were moving to regenerative agriculture, as you as practitioners are trying to have the skills to communicate about climate and ecological function and soil health, and to help them make meaningful and realistic decisions about what they're able to do on the land that they're managing. As you write grants, because you want to get money to help support these things, you have to think about, how does this work? And it's a sustained and iterative process, because we're working, it's one of those things that's so complex, because we have what's going on today. Climate has changed today. We have all these models about how we predict it to change in the future, but our actions now determine how it's going to change in the future. So we have to continuously be reviewing and assessing. And so you have to consider both the current and projected, and there's that huge variability. And adaptation actions are not limited to just awareness and assessment and planning, but they have to be implemented, monitored, and reevaluated at pretty decent intervals to be able to really show that you're on the right course, and you have to be able to change based on what's going on. And I think and the added complexity of this is resources. So, someone mentioned the $20 billion, like that's just us. There's lots of money coming from other different ways also that could change your decision, because it might change the economics of it. So that all gets put together for that. So real quick on economics, there's a link to this. I just want to mention this because in my opinion, this is one of the best economics resources that I found when you're talking about trying to understand how economics plays a role in farmer and rancher decisions. This is through Washington State University. And this is, they are truly case studies. And I think case studies is one of the easiest ways to communicate economics, because you can get a balance sheet and you can talk about cost benefits and all that kind of stuff. But as practitioners, it's like, that's great, that pencils out, but like what was the reason that person asked those questions about their operations that led them to make that decision, that led them to do the analysis, that led them to seek out those tools like AgBiz Logic, where they could take a Saturday or a Sunday or their evenings and like enter in the detailed information of their farming operations so they could decide if they have the information to make it. And the thing about these case studies is they do that. These farmers and ranchers have opened up their processes in their lives to help people understand what they went through to make these decisions, and are willing to share that with all of us. So as when it comes to economics, nothing we do will be successful without considering that piece. And there's not a really amazing one-shot way that we can talk about it, but I have found that this resource is helpful from a practitioner standpoint of being able to review the logic that went into it. And just telling stories. This is just Oregon soil health success stories. There are tons of soil health success stories around the country. We're due for doing a few more of these. We took a bit of a hiatus on some of our content development during the height of the pandemic. So we're looking forward to doing some more success stories, because people have done a lot of work. But it's good to see Oregon faces and know that this work is happening in Oregon. And these stories don't go into the economics, but they do talk a lot about the way that folks were thinking about it, similar to the quotes that Hannah put up in her presentation. So I want to go back real quick and quickly talk about programs. So I don't have a program specific slide, because there's nothing new that I can tell you about programs now, so I want everyone to just know that we are now 3 business days into the new fiscal year for the federal government. So all of that money that's coming, it's been 3 days. So we haven't really heard about how that's all going to roll out yet. I can say that I am working with the group on I'm part of a much larger group who's working on NRCS's implementation of our adaptation plan. And your questions about how programs are going to roll out are the questions that this group is really trying hard to answer. So I would say for now, hang tight. expect all the great service that you would normally from the USDA, from Farm Service Agency, from NRCS with our environmental quality incentives program and our conservation stewardship program. And once we know, the second we know what that means for Climate Smart specifically, we will make sure that you all know as well. We are anticipating, bigger budgets. With the 23 is a ramp up year, and 24 and 25 are going to be more of the big budget years. So this is kind of our year to get our heads wrapped around what the expectations are and what we can do. And we're looking at the whole gamut of options from, paying more for practices to delivering more contracts to, streamlining things. So we're trying to look at all that stuff. And I think you'll hear about this later, the state of Oregon is also looking at what they're going to do for practices and programs for soil health and climate as well. So it won't all just come from the federal government. With that, I think I finished within my time, Ashley, I hope. Yay, good. I'm happy to answer any questions.
Thank you, Cory. So if people want to raise their hand to ask a question, we do have a couple more minutes for questions, or you can type them in the chat. And Megan, I don't know if we've gotten any so far that are good to ask for Cory.
Not questions so far, but there were some other really good resources shared. So let's see, scrolling up through here, was a couple of other cover crop selection tools, and the Western Cover Crops Council that Cory also discussed. But if someone has a question, please unmute yourself and ask, or raise your hand. And I think, Ashley, if I'm not mistaken, a lot of these resources that people are putting up in the chat as part of the conversation, as well as those from all of the presenters and their slides, will be shared in another file document, emailed or shared through a Google Drive link to everyone.
Yep.
Yeah.
And it looks like Nick, you have a question. Do you want to go ahead and unmute yourself and ask it?
Yeah, thanks. I just put it in chat. I was just wondering if anybody has experience using Comet. I'm working on a proposal that it might be relevant for, but I'm clueless about it. So if there's anybody with experience with it, I'm interested in collaboration maybe.
Nick, I might know a couple people you could reach out to.
Cool.
Comet, though I showed it here, Comet isn't necessarily a super helpful tool for a lot of Oregon specialty crops. So a lot of people go into it thinking, oh, this is great. And they're like, wait, this isn't what I need. Or doesn't have what I need, but it is something that, we're continually working on.
Yeah, there's a continuing classes that they teach in Comet pretty much every month. If you go to their website, they can link you to that. And I've been working on those. They're good classes.
Nicole, did you want to speak to that, or did you have another question?
Other question.
Go ahead.
Okay.
Yeah. Hey, Cory, thanks for that. I'm just wondering if you all are thinking about strategies to kind of increase capacity at the local level for technical service provision, technical assistance, with all the money that's coming and new opportunities, and NRCF's probably not doubling their staff. Any thoughts about how we build partnerships and use these communities of practices to help kind of get that information out there and connect kind of programs and money to folks that are doing work on the ground?
Yeah, absolutely. So we are looking at all of those things. We're putting our heads together quite a bit. We had a very robust Oregon leadership team in our last meeting in August. It was all about, all right, what is the multifaceted approach that we're going to have? And it does involve building capacity at most local service centers, but you're right. We're not going to double our workforce. We have about 175 people on staff. We wish that we were at 200. It's a lot of turnover, just like every other sector. We want to see that increase. Partnerships under the leadership of our state conservationist, Ron Alvarado. Partnerships and agreements and helping support capacity with our partners is a huge part of his conservation portfolio. And I only see that continuing, if not expanding, with this funding. So we'll have to look at creative ways that we can have that work directly be able to, help get some more of this delivery. So I wish I could have it all figured out for you guys. I really do. But like I said, it's like we're 3 days in. So until we can't really start planning until we actually see how much of that $20 billion, what it means for Oregon. Because, it's not like, it's a lot, but it comes in a lot of different ways, if that makes sense.
Thank you all so much. I think it's about time to wrap up. And thank you, Cory, for managing those questions when it's so hard to know what's coming up, and for the amazing PowerPoint presentation. I think we're going to have to hold questions for now. I'm sorry that we're not able to get to all of them. I want to just pause and let everyone provide a nice round of applause for all of our presenters and folks for taking time today. I really appreciate it. So excited for next week's conversation, where we're going to dig in a little bit more to communicating with producers around climate resilience, the challenges of that, and what people have found useful to navigating that space. And for folks, if you have any feedback, I'm putting a form in our chat. So if anything came up for you today that you had problems with or have questions about, feel free to fill out that form and let me know. We'll have a more comprehensive evaluation at the end of all of our workshops, but thank you for your time and attention. And I know the registration was a little tricky and sign on for some folks today, so thanks for navigating that. We will figure out if we can do anything on our end to make that smoother next week. So thanks again. I really appreciate your time and attention, and I look forward to next week. Take care.